Today we're going to be learning about exponents. Before we begin, there are some important vocabulary words we need to go over. The first one we need to go over is the base number. The base number is the number that is used as a factor. In this case, we have 7 to the second power. 7 is our base number. I also remember the name base number because 7 is at the base of this expression. So it's what forms the foundation or the base of this expression. The next word we're going to go over is exponent. If we go back to our example problem, we see an exponent of 2. The exponent tells us how many times we're going to use our base number, 7, as our factor. The next important word we need to go over is power. Now, a power is related to an exponent because numbers that are expressed using exponents are called powers. So if we went back to our example, our 7 to the second power, our exponent refers to the power that the base number 7 will be raised to. Our last two words that we have to go over relate to powers. They are squared and cubed. Now, they relate to the word power because sometimes when base numbers have special exponents that are raised to a certain power, they are referred to as special terms. Some things are numbers squared and some things are numbers cubed. In our example problem, 7 to the second power is the same as saying 7 squared. Anything to the second power is squared. If we had something like 3 to the third power, that is 3 cubed. Anything to the third power is cubed. When you're working with exponents, there are two ways to express powers and products. The first that we're going to go over is to write a series of factors using an exponent. Sometimes you'll see this as example directions on a quiz, test, or a worksheet that you're working on. If you're writing a series of factors as an exponent, you might see something like this. You might see a problem that's 4 times 4 times 4 times 4 times 4. Now, if we wanted to write this series of factors using an exponent, we would use our 4 as the base number because that is the factor that is being multiplied over and over. So that would be 4 as our base number, and now we need an exponent to add. Our exponent is the number that tells us how many times we're multiplying that base number by itself. So all you have to do when you're determining what exponent to use is count how many times your base number is being multiplied together. In this case, we have 1, 2, 3, 4, 5 4s that are being multiplied together. So this is 4 to the 5th power. So if you ever see something that says write a series of factors as an exponent, you're going to see a multiplication problem much like this, and you'll just need to write it as a base number with an exponent. And we would read this as 4 raised to the 5th power. Before we go on any further, I want to point out a common mistake that students often make. A lot of times, if students see this problem, 4 to the 5th power, they think that that's just 4 times 5, which equals 20. That is incorrect. First of all, your base number is 4, so you are multiplying 4, but that exponent does not tell you what you're multiplying the 4 with. It just tells you how many times you're multiplying the 4. So you have to get it in your heads and just remember it that 4 to the 5th power is not 4 times 5. You're multiplying 4 by itself 5 times. The next way you'll see a type of exponent problem sometimes would be to write a power as a product of the same factor. And that sounds a little tricky, but once we go over it, you'll see that it's really nothing that you haven't seen before. So if you're asked to write a product of the same factor, you might see a problem like this: 7 to the 3rd power. Now, if they're asking you to write that as a product of the same factor, you're starting with a base number and an exponent, and you have to basically write it in expanded form like we have up here with the 4s. So if you see this, it's almost like going in reverse. Our base number is 7. So that's the number that we're going to be multiplying over and over. And the 3 is our exponent, which tells us how many times to multiply the 7 by itself. So that will be 7 times 7 times 7. Again, this problem is not 7 times 3. The 3 is not a factor. The 3 simply is a power or an exponent that tells us how many times to multiply that 7. So that is incorrect. Please make sure you know the difference. The 3 is not a factor. It simply tells us how many times we're going to multiply the 7. In a lot of exponent problems, you'll be asked to find the value or evaluate the expression. Remember, evaluate means to solve. We're going to go back to our last example we did of 7 to the third power, and we're going to find the value of that expression. So we want to find the value of 7 times 7 times 7, or 7 to the third power. So we actually have to do the math here. So now we need to figure out 7 times 7 is 49. Then we also have this last multiplication sign and 7 to bring down. Now we're going to do the math problem of 49 times 7 off to the side so we can find the value of the expression. 49 times 7. 9 times 7 is 63, so we leave the 3 and regroup the 6. 7 times 4 is 28, and then 28 plus 6 is 34. So if we were to find the value of 7 to the third power, or 7 cubed, it would be 7 times 7 times 7 equals 343. Now, on your own, what I want you to do, on the backs of your paper, you're going to write numbers 1 through 4, and you're going to complete the next 4 problems based on what you just learned. If you need to go back in the video at any point to re-watch something so you know how to solve a problem, go ahead and do it. Number 1 is write 4 times 4 times 4 times 4 using an exponent. Number 2 is write 6 to the third power, or 6 cubed, as a product of the same factor. Number 3 is write 2 times 2 times 2 times 2 times 2 using an exponent. And number 4 is find the value of 3 cubed, or 3 to the third power. And please take this time to pause the video and work these problems out carefully. And again, if you need to go back and re-watch anything, go ahead and do it. Since we're at the end of our concept, this is where you need to stop and think. Do I understand this concept? Should I write down some things I don't understand? Or do I have any questions I need to ask in class tomorrow? If you do have some questions, like you don't know what a word means, or you don't know why we multiplied something that we did, please make sure you make note of that and bring it up in class. Chances are, if you had a question about something, a few other people might have had the same question.